International, and I'd like to welcome you to the 2020 Virtual VM Conference. Thank you for taking a few minutes to learn about CSI International and some exciting offerings coming this year. Don Stoever, our Director of VSE Development, will share our new work on security, efficiency, and talented VSE developers. Then John Rankin, our company's founder, will demonstrate network folding, our patented solution for transferring large amounts of data over the internet with virtually no data retransmissions and at unbelievably fast speeds. We're honored to share our progress with you, and we look forward to seeing you in person next year.
Hello, VM Workshop. My name is Don Stoever with CSI International. Thank you for attending this virtual conference. We'll be going over our roadmap forward for security, encryption, and speed, and specifically TCP/IP. Just want to let you know a lot of things are evolving and changing here at CSI. We have some new people, and this is the top team of people that are available here at CSI to communicate with. Give us some names there. The agenda for my session today, I'm going to talk about the elephant in the room, which is meaning things that are obvious but nobody wants to talk about. We're going to talk about the security problem that currently exists, and then I'm going to go into our TCP/IP on Z updates. So what do I mean by the elephant in the room? Well, there's some problems here that we need to talk about. We have increased workload requirements on many ZVSE systems. We're seeing, even though our customer base may not be expanding, the amount of work being done on their systems is growing workloads, and they have very limited budgets in most cases. So CSI is going to be trying to get more done with less by finding efficient ways to help your data center be more productive and hopefully reduce costs. We're seeing a big problem with talent. There's a talent shortage problem. Key personnel retiring that had intimate knowledge of your systems. One of the ways we're addressing this here at CSI is we've recently started an apprenticeship program where we're looking for new young talent that we can train and get involved in the mainframe. And we're cooperating with IBM on this. There's also, certain colleges around the country having good mainframe education programs. Security threats are increasing. Everything is moving online and everything is moving to cryptography. We need to secure more and more as requirements and to provide a safe, secure environment for our businesses. A little more detail here on the security problem. I'm sure you're aware of there are many regulations, PCI, payment card industry, health, HIPAA, the European General Data Protection Act, many more. It seems like there's new requirements coming all the time. And I think that at this point, rather than fighting against them, we probably need to embrace them, because ultimately they do make our most important asset, your data, our data, better secured and better for better integrity of our systems. Secure communications require specialized configuration hardware. We were at the forefront of this back in '98 when I started the connectivity systems. We implemented the SSL 3.0 protocol. Back in those days, there were not available any hardware. We had to write most of the algorithms in assembler, but now we're able to do that with many hardware facilities. TLS 1.2 is now the accepted standard for compliance. The older versions, SSL 3.0, TLS 1.0, and 1.1, are considered compromised. Encryption of all data. Wow. The world is moving toward pervasive encryption. So our data at rest should be encrypted. And that's going to take a lot of work and planning to do. Authentication of your systems. User ID and passwords are not enough nowadays. We have, two-party authentication of who you are accessing the system and or one system accessing another system. And a lot of that is being done by using certificates, which falls under the public key infrastructure. So certificates and management of them is becoming a bigger issue. talk now a little bit about TCP/IP for ZVSE. We have a new version just released here in June. 2.2.8 has many new features, a lot of enhanced security, and its focuses on encryption. Some of the things in this new release is we support the TLS 1.2 protocol. We have a firewall feature that provides security by default, meaning unless you're specifically allowed access to a resource, you can block, deny it being accessed. One option in that firewall is you can also use it to monitor your IP activity in warn mode initially before you implement full fail mode. We're also now supporting a couple of utilities using asymmetric RSA keys, so you can pass sensitive information securely. So on one end, I can give you my certificate. You can encrypt some sensitive information, passwords, and send it back to me, and I'm the only one who can decrypt it. Those are our EPAS and DPAS utilities. So we're also allowing you now to supply your own symmetric AES keys. This was in a specific real-world user requested the ability to do this. And this allows you to pass us the raw key material in our common encryption cipher interface. FTP is a heavily used component, and we get a lot of issues in it. You spoke and we listened. We're trying to make it easier to implement data connections in a secure fashion as well, using SSL and TLS, as well as identifying what ports can cause problems. We've reduced use of our 24-bit storage, freeing up that. We now also support variable length records with the site record descriptor word on, so you can pass variable length records a little easier between different platforms. And we've improved the security and performance of the FTP batch utility. Some other enhancements we've recently put in is the OSA Express are now using 31-bit real storage, reducing our 24-bit real storage footprint. We have improved diagnostics for external partitions, so applications running outside of the TCP/IP stack can more easily be diagnosed when problems occur. We've improved our TN3270 server to provide additional diagnostics and statistics. And we're providing performance data to the Velocity performance monitor, allowing it to see into what's going on within TCP/IP for our partner Velocity in that area. We've made steps towards implementing the OpenSSL and for the store instruction in SIIS support has been a big topic lately, where separation of data and executing commands is now more making it more efficient, so we can exploit the ability of the latest and greatest IBM CPU technology. And many more upgrades are coming today. The future of Z. CSI is trying to integrate all of our product integration, so we're focused on security and management. We have new products coming for ZOS, ZVM, ZVSE, and Z Linux. So we want to be the one, we're helping bridging the mainframe into the cloud. So the future of VSE looks bright on the Z platform. We have the network folding coming out, which will virtually eliminate retransmission problems. It's going to be supported initially on ZVM, ZOS, and ZVSE. It'll allow moving of big data over a long distance quickly and efficiently. That's coming soon. We are doing a lot more strategic planning at CSI. So we need you to tell us what you need. Help us, help you. We'll put it in our roadmap. We'll listen and get it into our plans. And that will, of course, help us, and we can all prosper together. What are the next steps coming? There are many new improvements. At CSI, we're going to be launching off a new website pretty soon. a customer portal to allow you to interact more easily with issues on products. We're going to provide full security audits to provide improved security and encryption focus. And lastly, I want to mention that we're going to have a demonstration of network folding immediately following my part of this session.
Good afternoon, everyone. My name is John Rankin, and I'm with CSI International. And I'm here to give you a bit of a demonstration of a new product, a new piece of software, really, that we've been working on here at CSI that we're very excited about. It's called network folding. And the objective of network folding is to improve the efficiency of how the internet works, specifically relating to transfers of large amounts of data over TCP. Generally, there's a lot of congestion that occurs in the network that begins to cause problems. The protocols were developed a long time ago, and they suffer from a few minor flaws. And as a result, from time to time, you'll find the network jamming up and transfers not being smooth. They'll start and stop as it goes. And so we've been working very diligently on this problem to try and isolate exactly what causes this and how it can be corrected through protocol changes. So you can see here we have in front of us a little bit of a demonstration that I'd like to show you, because we've reached some solutions that I think you're going to be very excited about. So first of all, we have, and you can see the cursor moving around here, we have three VSE machines under VM, and these are their operator consoles. So this is machine 1, this is machine 2, and this is machine 3. And what we're going to do here is this first machine is going to function as a client, and this last machine is going to function as a server, and the central machine is going to function like a router. And what we're going to do is we're going to route a file transfer from the server to the client and through this central machine. Now these are VM user IDs that are set up using ZVSE and TCP/IP, and we've got we have CTCAs that connect the three machines together. So it's not using a traditional network, it's a very specific network, and it's specifically designed because it's to set a baseline so that we can reproduce behavior. So let me demonstrate what we're going to do here to begin with. So we have a small job stream, and let me bring it up and I'll show it to you. You can take a look at it here. And I've got it set up. It's called VSE test job. And as you can see, it's a FTP batch program that executes, and it simply logs on to an FTP daemon and then transfers a file called $null to a file called $null, which in our particular world means it's about a 10 megabyte file, and that eliminates all the I/O. So we're just really testing the network speed. That's all we're doing. So this is just a very simple program that we're going to run, and I'm going to go ahead and submit this over to the VSE machine. So it's VSE test job A, and it's going to go over to our test environment. Okay, so it's been sent, and now I don't need this screen anymore, so it's over here. And then when we run this job, what's going to happen is it's going to log on to an FTP daemon on this third machine and transfer a 10 megabyte file. So that's relatively simple. So let's give it a shot. We'll take a look and see. Again, the objective here is to just set a baseline as to how long it takes to do that. So, and okay, it was relatively quick. You see the FTP daemon executes over here. It's traveling through this particular machine as a router, and it's arriving here, and you can see it took a total of 3 seconds. You can see that there, and we can go take a look at the output of that job if you'd like, because it came back to our reader queue under VM, and we can take a look and see that it runs reasonably fast. It's running at about 10.7 meg per second. So that's pretty fast. I mean, given the environment. And again, the environment is under VM, and it's using CTCAs. Okay, so that's really what we're going to do to begin with. Now, I'm going to clear the screens so that we have a nice clean slate to work with. And I'm going to go to the central machine, and I'm going to do a little bit of additional stuff. I'm going to say set congestion equals 20, and I'm going to say congestion on. Now what I've done is two commands that are not actually in your TCP/IP. Don't try and use them. These are something we set up specially for this examination. What this does is it tells the TCP/IP stack that's acting as a router to throw away every 20th datagram. Now this simulates network congestion, or more specifically packet loss. So that's the objective here, is to try and simulate what happens in an actual environment when the network becomes congested. And that's what happens with the TCP protocols. When the environment becomes sort of stagnated and there's just too much stuff going on, it will begin to throw away data. It'll start to, and it'll force retransmissions. So that's what we're going to do here. We've turned on congestion and we're going to force a retransmission. So we're going to rerun that job, the same one that we ran a minute ago, and we'll see how that looks. Take a second. Are you ready? And we're rerunning, and obviously it takes a little longer. It's going to run for a bit. So you see the FTP daemon here over on this side of the world has started to execute, and we can see that over here. There's the FTP daemon logging on, and here's the job running over here, and you see it's still continuing to execute. And this machine again is acting as a router, and it's creating this 5% congestion. Now 5% congestion is a typical amount of congestion that you might find in the internet. It's very common. We've done some checking with the IETF and a number of other agencies that actually do a lot of monitoring the performance and congestion on the internet itself, and we've discovered that 5% is about a typical amount of congestion when the internet does become congested. Now, of course, the objective is for the internet to remain smooth, continue to operate if you have enough bandwidth, but not everybody has enough bandwidth, and there's not always enough bandwidth from end to end. There may be bandwidth within the main backbone, but not enough bandwidth getting into your building, depending on how your networking is set up, and you can have a bit of congestion that goes on. And in this particular situation, it's illustrating that obviously a 5% congestion, which isn't much, does create a tremendous amount of performance problems for TCP. Now, we've tested this same scenario with VM and ZOS as well as Z-Linux, and we have similar results in those environments. None of these mainframe-oriented stacks, nor do the stacks on PCs or other platforms, they're not able to handle this particular problem. The problem is beyond the scope of how the protocols are designed to deal with this situation. So as you can see, we're still continuing to run. It's a relatively costly problem. Just this 5% congestion is creating a significant amount of performance delay. As you can see, the job still hasn't completed yet. And so we were very concerned with this a number of years back when we started realizing that the internet was going to continue to grow. And so we worked on network folding to try and resolve this problem. Now you see the program's finally finished. The FTP session has finished running, and it took a total of 2 minutes and 12 seconds. 2 minutes and 12 seconds. Now let's go take a look at that, the output from that job, and see what our timing looks like. And we can take a look here, and we can see that it's running at about 80K per second. So that's not particularly good. It's a bad situation, and that's certainly an illustration of congestion problems. So what we're going to do now is we're going to make a minor change to each environment. I'm not going to change this central machine. I'm leaving it exactly as it is. We'll leave the 5% congestion alone, and we're simply going to say network folding on. So this is a process of turning on this new piece of software that we have developed here at Connectivity Systems. And we've turned it on both machines. So it's running, it's on both machines, and then we're going to re-release that job. And it is, again, VSE test. So we're rerunning the same job with the 5% congestion as it was. And, oh, it's done. Took 4 seconds. So I have to scroll back a little bit because it rolled off the screen. So as you can see, it took 4 seconds to operate, and that is with 5% congestion. So if we go take a look at that output stream, there it is right there. Here's the listing. Take a look and see, and you know, it's about 4 megabytes per second. Now it's not the 5.7 meg per second that we saw in the test without any congestion whatsoever, but to be able to still maintain a 5 megabyte per second transfer rate through a system that is 5% congested is a pretty significant thing. So that is what network folding does, and network folding eliminates the problems that are caused by the protocols and their inefficiency to be able to deal with the congestion problems. And let me just illustrate this a little bit more by making another minor change. We're going to do this. Again, I'm on the router now, and I'm going to say set congestion equals 2. Now, what that says is that's saying, I said set congestion equal 2. What that's asking the system to do is allow me to change this to a 50% congestion rate. So every other datagram is being discarded, and that is quite a problem for a TCP environment. 50% congestion. If I ran this on our standard setup without network folding turned on in a VSE environment, it would take 30 minutes. VSE to ZVM doesn't even complete. ZVM doesn't have the protocol strength to be able to even handle that kind of congestion rate. So we're going to run the job again. We're running the job now with 50% congestion. And it's not going to take 3 or 4 seconds. That would be way too much to ask. But it will complete. And as I said, when we tested this without network folding on, it took a half an hour. And then hopefully we won't sit here for half an hour. Oh, no, it took 16 seconds. So 16 seconds, and if we go take a look at the output listing, see what the actual transfer rate is recorded at. See, well, a little bit less than a meg per second. Not particularly great, but considering that we are driving that 10 megabyte file, see, it's 10 megabyte file, so we're driving that data through 50% congestion, I think that's pretty impressive. So network folding is a significant advancement here at CSI. We're very proud of this work, and as a result of this new technology, Connectivity Systems, or CSI International, as you know it, has actually received a total of 3 United States patents that have been granted by the federal government on our company. One just a few months ago that actually relate to this technology and underscore the value of it for the industry. So we're very, very, very excited about network folding and its potential. And we should be implementing a version for ZVM and also a version for ZOS and ZLinux, and also for the Macintosh and for Linux and for Windows and for every other environment that we can implement network folding on and have it available as soon as possible. So obviously it's working here in the ZVSE environment, and this should make a significant difference for people that have things like backup tapes that are virtual, or large files that have to move from one place to another, or any downloads, things of that nature. Anytime that you have a large amount of data that's transferring and you're really concerned about making sure that it gets there, and it gets there consistently and effectively. So that's pretty much it. That's what I wanted to show you today, and thank you so very much.
All right. Thank you so much for everybody. Now we're going to open it up to questions from anybody here that have questions for the CSI team. Feel free to unmute your audio and go ahead and ask. We have Don Stoever and John Rankin right now on the line and available if you have any questions.
Yeah, this is Don Stover. I just wanted to give a shout out and say hello to everyone. It was a pretty short session. Appreciate everyone listening in today, and welcome any questions. We'll be around. We have
a question from Steve. He wonders what it does to MFT products.
Eric, this is just John Rankin. Can everybody hear me okay?
We sure can, John. Go ahead.
Yeah, again, I'm not entirely sure what he means by MFT, but I can say that it has a significant improvement over any product that uses TCP. So that's how it's designed. It's designed to handle anything to do with TCP IP. It completely eliminates, well, not totally, but it pretty much eliminates effectively all retransmission problems and allows everything to be streamlined, and significantly improves the overall performance of TCP in any environment. So that's what it does.
That's great, John. And Dick is also asking if it's VSE to x86. And, to reiterate what John just said, absolutely. So we're releasing network folding. It's going to be architecture agnostic. So we look at releasing this for all different platforms. It'll be more operating system dependent. So we have it on ZVSE, ZVM, ZOS, Windows, and Linux stack as well.
Yeah, exactly. I mean, we developed it obviously in the VSE environment because that's the environment that we're most familiar with, but we plan on having network folding on every platform that we can possibly get our hands on. So and it should be law if you're moving from VSE to x86 or to Linux or to ZOS or VM, or you're doing any of those kinds of things, any mixer matches, not a problem. It'll work on all those environments.
We have another question about ZTPF, and again, yes, we're focused on releasing this on the different platforms on Z and supporting them. The order of priority, we have it fully functional on Z VSE right now. ZOS and Z Linux and ZVM obviously are the next full releases for this product. We want to play in the sandbox that we know best, and CSI has such a long, rich history, having been the first people to develop the TCP stack on ZVSE. We're going to focus on what we know best, and it's going to be mainframe.
Yeah. And now, as far as TPF is concerned, we do have a long-standing relationship with IBM. We've been working with them for over 20 years. And, I'm very excited to work on TPF. We've actually been negotiating for a couple of years to get a development license for that environment. So a long-term goal is, in fact, to support ZTPF. I think that would be an excellent solution. So,
great point, John. And Aria is asking if we can provide a summary on how it accomplishes that. Well, we can't give away the super top secret stuff, but John, do you want to address how we can accomplish this?
Well, I would love to talk about that, but I'm afraid the technology would take more than the time we have allotted to talk about. But all 3 United States patents are, in fact, available on uspto.gov. If you go look up connectivity systems, you'll find the patent work there, and the technology is readily available for anybody to read if they're interested. It's a little bit mumbo jumbo because it's a United States patent, but I'd be more than willing to talk offline with anybody that wants to discuss it. It's all protected technology, so it doesn't bother me in the least. And I think we're very excited about it. So any questions we get, but we just don't have enough time to talk about it here.
Okay, and then we have another user that's curious if it works in conjunction with network-based vTape. And again, absolutely. Anything that uses the network will benefit, especially if it's moving large amounts of data across heavily congested or heavily utilized networks. You will benefit from the use of network folding.
Yes, that's exactly right. That's exactly right.
And Steve is asking, MFT, he's verifying it, such as Connect Direct or Axway, etc.
Oh yeah, absolutely. Those are based on TCP, so yes, not a problem. It should definitely improve, and the effect you'll see is that everything will work as it normally does. It'll just suddenly be reliable and effective. You won't have the kind of delays that you normally see with transfers where things stop and start and stop and start again, or maybe have to be redone. So that's what it eliminates.
And just to reiterate to all of our amazing participants in this conference right now, we are actively looking for beta users. We have a huge base of VSE customers, obviously, but if you're interested in using this technology, reach out to us. And Katie's information, Katie Shaw, is up on the screen now. Please reach out to her, send her an email, give her a phone call, ask her if you can get in on our beta program from Network Folding. If you have, point-to-point transmission or, massive backups that are going for disaster recovery, we can almost guarantee you will benefit from this technology. Artie's asking John if there's going to be any issues with steelhead devices like WAN compression appliances. I don't think so.
No, it shouldn't make any difference.
Yeah. I think fundamentally the way that this is working is this is just using the existing TCP protocol in a way that it wasn't thought of how it should be used before. So it's just minorly altering one function of TCP to take advantage of its currently existing abilities, which John Rankin, the genius behind this, figured out a way to do that and exploit it.
All right. Well, John, Don, and Eric, thank you very much for giving us an update. Very interesting stuff.